Hello, today I'm going to show you how to reduce ARCoIRIS data using the module that was written for the Spextool package. So you should have already downloaded the Spextool package as well as the ARCoIRIS specific module. And if you go into the Spextool directory here, what you see is directories here for instruments, one that you might be interested, the directory here that has manuals. The Spextool manual and the Xtel Core manual might be ones that you find useful for other tips and tricks on using Spextool. Okay, if we go back here and we go into the instruments directory, here in our ARCoIRIS directory, this is where our package lives. One thing to note here that you might find useful is the README file. The README file contains installation instructions, some information on how to run the package for ARCoIRIS, and some of it is specific if you are familiar with Spextool, some of the things that you have to do a little bit differently for ARCoIRIS data. So a little bit on how to run Spextool, and then most importantly, down at the bottom here, we have information on how to cite this reduction package. So this package is a modified version of Spextool, so you need to make sure to reference in your publications the 3 papers that are related to Spextool. So please make sure and do that. Another thing to point out in this directory is this example calibrations directory. Oops. In this directory, what you'll find are some dome flats and wavelength calibrations. And these are in particular, if you're not able to get the CALS module and Spextool working, these are a great backup. Because ARCoIRIS has it's a fixed instrument, so nothing should be changing. So although these dome flats and arcs are not going to be specific to your run, they still can provide a rough calibration. Okay, so you're going to want to set up a working directory for your ARCoIRIS data. So in this case, I've set up an example directory. Within this directory, you're going to want 3 subdirectories in which you'll be doing your data reduction. Okay, so what we have here are the cal, proc, and raw directories. The raw directory should include all of the FITS files that came from ARCoIRIS. And within that directory, one thing that is important, ARCoIRIS has the ability to write out expo files where you would have a file name that's identical to the standard differenced FITS file. And if those are in your directory, Spextool will not like it. So what you need to do is if there are expo files, you need to put them in a separate directory. Essentially, in order for the package to work, the numbered files in the raw directory, you can only have 1 file with each particular number. Okay, so that's the raw directory. The cal directory is where our calibrations are going to be stored, and then the proc directory is going to be our working directory where the various stages of the reduction will be stored. So we're going to go ahead and go into the proc directory. Okay, so we're now in the proc directory, and from here we will just start up IDL, and we will start up Spextool. To start up Spextool, the command is x Spextool. Okay, so this first page shows, this is the Spextool first page here, and this is where you set your directories. So what we're going to do is we want to set these to our raw, cal, and proc directories that we have in there. So you can either type these in, or you can click on the button beside them, and then you can actually find it that way. So either of those are fine ways to do it. Okay, and once you have that, what you're going to do is click on the CALS button here. So this is where we're going to create our calibrations, flat field and our wavelength calibration. So there's a few things here to note. First is this raw orders 3 to 5, and you can see that there are separate places for you to put in flat fields for orders 3 to 5 and 6 to 8. In data that was taken prior to 2016, flats were taken with 2 different illumination levels, and so this is written to be able to accommodate that data. However, if you have flats that were only taken with 1 illumination level, where you only have, the flats with the lamps on and frames with the lamps off, all that you have to do is enter in the numbers for those frames into the raw orders 3 to 5 flat images boxes here. So we're going to go ahead and enter these in. So let's say my raw flat frames are 20 to 31, and my orders lamps off here is going to be 70 to 61. And now what I need to do before I can run anything is I need to change my input prefix. So what you may have noted, let's actually take a look at that raw directory again. If you look at the raw directory here, you can see that there's a prefix, and then there is 4 numbers and then .fits. So the input prefix here in Spextool needs to be everything that comes before the 4 numbers. So in the case of my flats, it's this sort of long spec underscore flat that I'll need to have in there. Okay, so once I have this all set and I entered the numbers in, I'm ready to go. And what I can do is I put in my output flat name here, and I will go with a very creative flat. One thing to note in Spextool is as you're running through your reduction, anytime that it asks for an output file name, you don't need to include a .fits extension. So just go on ahead and just put in the name with no .fits attached. And then we can hit construct flat and it will go through this. Now, if for some reason it doesn't find the files and you're having issues putting the numbers in, what you can do is actually, if you click on the raw orders, you can actually select your files in here as well. So that's another option if you would prefer to do that instead of putting in the numbers and doing it by index. If you choose to do that, however, we'll cancel out of this. If you choose to do that and select the files themselves, you will want to change your file read mode up here from index to file name. Okay. Well, we have the numbers in here and we are ready to go. Oop, I don't want 70 to 61, 70 to 81. So we can go on ahead and construct the flat. And this is going to take a little bit. It actually is going through and tracing out the edge of all of the orders using the outrigger slits. So it has now done this for the orders 3 to 5, and then it treats these a little bit separately. And in the end, what you'll wind up getting is a flat field that has been normalized and should be there for all of the orders. So this is a very typical looking flat field for ARCoIRIS. You can see that there's some kind of strange structures and all of this, but this is very typical for what we get from the instrument. Okay, so that's it. We created a flat field. That was pretty easy. All right, now we need to create our wavelength calibration. And when you move into doing the wavelength calibration, you actually have a couple of options. You can either use arc lamp images, or alternatively, if over the course of the night you've taken some long exposure data, say you have exposures that are longer than about 60 seconds, you can actually use those to create a sky using the OH lines. For this particular data set, I'm going to use arcs that were taken with the copper, helium, argon. And let's see here, my numbers for those are 103 to 107. And the prefix for those is spec underscore arc. That's what I had when I saw them in my raw directory. You can see that this actually nicely pulled over the name of our flat field from the one that we created over here. And the other thing we need to make sure and check here is because I'm going to be using the arc, I need to select that I'm doing the arc instead of the sky. By the way, if you choose a sky frame, your sky frame, if you have a faint object in it, that's totally fine. You can actually, it does a wavelength solution, even if you, even if it's not on a blank piece of sky. Okay, and now we're going to output our wavecal here, and again, I'll use the very creative name, wavecal. And we'll run through the wavelength calibration. Okay, so it goes through each order, and the package actually has initial guesses for where all of the arc lines lie. And so it finds them and it creates a 2D wavelength solution for the imager. It also, as it does this, goes through and it will let you know if it's having any issues with particular lines. So in this particular case, it's not. This looks like a really great ARC image. So we can quit out of that. Okay, so that basically sums up how you set up Spextool to use with ARCoIRIS. In the next video, we'll talk about how you go into actually extracting the data for your individual source. Thanks.